Welcome back. Given that we identified at least two main IDs that contain two separate users who were merged together, we are going to want to do a further analysis of the ID graph and one of the underlying tables. In this video, I will show how to use the PB Auditor tool, as well as how to run some manual queries to see if we can find the other ID values that caused users to get merged. We will take a look at the PB Audit tool first in order to QA our ID graph. The PB Auditor tool is a Python program that runs locally. If you are developing within the web app IDE, there are a few things you will need to do in order to set this up that our documentation will walk you through. Once you have the PB Auditor downloaded, you will also have to download your Profiles configuration project locally, as well as download the Profiles CLI builder. Also note, this tool solely works on a full rebuild of the ID graph. So if you have been running it incrementally, you can either change the ID Stitcher model spec to do a full rebuild by adding discrete to the run type key, or pass an additional parameter to the PB run command. In the latter scenario, you would run the command PB run rebase incremental within the CLI. Let's do a full local run so that we can then run the PB Auditor tool and do an analysis of our ID graph. Within my terminal, I will run PB run. Once the profiles run is complete, we will run the CLI command, PB Audit ID Stitcher, in order to start an audit session within your terminal. In this video, we will solely do a high-level overview. You can refer to our docs for a more in-depth understanding of the tool and its various outputs. The run is now complete. Let's now do a high-level overview of the analysis of our graph. I will now run the command, PB Audit ID Stitcher. The PB Auditor will have three main outputs. First, it will have a high-level pre-stitched and post-stitched analysis of your graph. Next, you'll have the option to perform a drill-down analysis of a specific main ID and to visualize its graph. And finally, there is an optional interactive LLM question and answer session that you can enter into. In this video, we will only review the first two outputs above. Let's look at each step one by one and see if we can figure out what caused the overstitching for one of the main IDs we found that had multiple merged users. The first output is the high-level pre-stitched analysis of your internal edge table. PB Audit will output your entity, ID types, and the number of ID values discovered on the latest run per ID type. It will also show you a total ID value count as well as the total main ID count, and give you a consolidation rate. Beneath the consolidation rate, we see the top 10 nodes and their associated ID types. The nodes are the ID values. This represents how many records within the edge table these ID values were seen in. Beneath this sections, we can see other various stats on our nodes and edges. The next section is the post-stitching analysis. We can see the percentiles of the count of other ID values within a main ID, an average count of the ID types per main ID, as well as the highest count of ID types per main ID. Within this analysis, we can see that the highest count of emails within a main ID is 2. This is a good indicator that overstitching has occurred, given that, within this business context, we know that a single main ID should only contain one email. Lastly, we can see the top 5 main IDs by total count of other IDs, as well as the count per ID type. We can see that the highest offending main ID is the same one we observed in the previous video. It contains a total of 68 other IDs. Notice how this main ID also has 2 emails and 2 Shopify customer IDs. Let's now do a drill-down analysis of this main ID. Paste the main ID value within your CLI. PB Auditor will then output some further statistics specific to this main ID, as well as output an HTML file within a subdirectory called Graph Outputs. You can now open the graph within your web browser to see a visualization of all the nodes and how they are connected. We can now see each ID value within the graph. The color represents the ID type, which is indicated by the legend on the top right of the visualization. We are attempting to see how these users got merged. In this graph, we can clearly see there is a single node in the center that is connecting the 2 larger clusters of nodes. If you zoom in, you can see that the node value is D Perez. Judging by the color, we can see that this is a user ID type. So we can clearly see that these two users somehow have the same user ID, and that is how they were merged. Given that the user IDs are meant to be unique, this is a problem, and this is what caused the two users to merge. In a subsequent video, I will cover how to fix this. If you do not want to go through the local setup work in order to run the PB Auditor, we can still perform some manual queries within our Snowflake console in order to arrive at this same conclusion. Jumping back into our Snowflake worksheet, I am now going to run some queries against the edge table and the ID graph for the same main ID. The edge table consists of records that have the ID values extracted from each source table. The table constructs what we call edges. An edge is a single record that has a node on each side. A node in this context is a ID value and its associated ID type. So, an edge record will have ID1 and ID1 type and ID2 and ID2 type. We want to get an analysis of all ID values and how they are connected to the other IDs within the sources. For example, one of the emails within this main ID is david.perez@example.com. We want to see all the other IDs that were directly connected to this email. That means we need to analyze both sides of the edges. So we need to union the edge table to itself and get the counts of each ID type that were connected to a single value. To make things easier, we will also generate an array list of other ID values. So for each node, we can see the list of ID values directly connected to them. Let's now run this query. We see that the IDs that were connected to the most other IDs were the two email addresses, david.perez@example.com and devora_perez@perez.org. Each email has a number of ID values that they were directly linked to. You can also see that each email was directly connected to one user ID each. Remember that we are analyzing a single main ID, and these are clearly two separate emails that belong to two separate people. So we want to take a look at what these user ID values are. Let's sort our ID type column to observe the user IDs within this cluster. As seen in the visual graph of this cluster, we see that we only have one user ID. Let's look at the list of other IDs this user ID was connected to. Aha! We can see the two emails within this array. Also note, the email count for this ID value is 2. This user ID is clearly the cause of linking these two users together, thereby indirectly linking all their other associated IDs together, which resulted in one large main ID cluster. We now know the reason these two users merged together, and now we can choose how to fix the problem. In the next video, we will cover how to now apply this fix to the graph and rerun it.